This is question 13 on problem solving from section 1 of the 2019 ECAA. So we're told that a gentleman is making some trousers for his son, and he's making 4 pieces like this, but approximating for simplicity when he's buying the material that he needs a 15 by 38 centimeter rectangle to make each of these pieces. We're given 3 different widths of fabric from the shop and the price per meter for each of these. And we're told that the shop lets you buy lengths in multiples of 10 centimeters. Therefore, based on this information, what is the lowest possible price that he could pay? So where should we begin? Well, we can see that we're going to want to think of ways of arranging all these rectangles on a piece of fabric of one of these widths, while using as much space as possible and trying not to waste the space. And so let's just sketch out a few ideas firstly. And so if we consider the length of the fabric going this way, and we firstly think of 4 of these rectangles stacked up like this, pointing along their length, then is this an efficient use of space? Well, let's think about what the width of these 4 rectangles is firstly. We've got 4 times 15 is 60. And so how does that compare to the widths that are available? So we can see that we're going to want to use the smallest width to keep the cost down, and that will be 100. But is there a problem here? Well, clearly there's a large amount of space that we're not using. And so far this doesn't look great. So what can we consider next? Well, what if we move the rectangles into this sort of orientation? So it looks like we're going to increase our width across here, but what is this width exactly? So we've got 2 lengths of 38. 2 times 38 is 76. So now, again, if we use the 100, because that's the smallest one, we've still got a bit of space here, but it's not as bad as before. So maybe a next logical step would be to consider the width if we have all 4 rectangles going lengthways to use the maximum width possible. What would that look like? So if it looks like this, what's the total width? Well, 2 times 38 was 76. Therefore, 4 times 38 is 152. Now, how does this compare with our widths? We can see that we're going to have to use the largest one. So if it's in the 160, it looks like we're using the space rather efficiently because we've only got 8 centimeters here at the end that we're not using. So does that mean this is definitely the best option compared to the last one? Well, let's start to think about the length that we're going to have to buy. So we're told that we buy lengths in multiples of 10 centimeters. And so what would that mean for this option? You can see that we've got 2 widths of 15 going up here. That makes the length 30. And we can therefore buy the exact length that we need. And what about in this case? We've got 1 width of 15, and so what are we going to have to buy? We'd have to go up to 20. So there's a quarter of the total length that we're not using here, but in this option, we've got all this space within the width. And so it's not obvious at first which one of these is better, so maybe it's best to do the maths and work out which one works out cheaper. So how much would this cost? If we're buying 30 centimeters of this one, when it's £2 per meter, how much would that cost us? So 0.3 times 2 is 0.6, and that corresponds to 60p. So let's compare this to our other option. If this one was 60p, how much would this be? So we're buying 20 centimeters of this one, so £2.80 times 0.2, well, times 0.1 would be 28p, so times 0.2 is therefore 56p. And therefore we can see, as we noted, that they're very close, but this option with them all lengthways is the cheaper one. Now, are there any others that we haven't considered? Well, yes, but we've chosen these specifically because they maximize the use of space. And so we can be confident that this is indeed the cheapest one possible. So our final answer is 56 pence as the lowest possible price, which corresponds to B.